Hello, welcome to another episode of Convector Developer Office Hours. This occasion is going to be just me presenting the session. So, hope everyone has had a good week, and we'll start with the show today. So, we got a couple of updates for today's session. I mentioned last session that we were working on a new feature for Convector for interchain code invocations. So there's sometimes when you have one chain code, and one chain code for me is for example, like a whole project. Uh, let's say, for example, a dev registry or an asset registry or serial registry or whatever kind of registry you need. Uh, and this registry has to be consumed by another application, let's say a banking application or another registry that needs to verify some data inside the chain code. So in this, Fabric is very flexible and it allows you to make call between different channels and different chain codes. Each of them is going to have its own ledger, so you can make multiple invocations between them. I'm going to show you in this session a little bit of the code. The code is already on a pull request on our GitHub. So if you want to pass by and leave a comment and in the pull request if you think there's something need to be added in the controllers that we're adding for this. It's actually just an adapter, so Convector is pretty flexible and it works through adapters to make invocations to different targets. And this is no different. Actually, we just to be able to bring this feature, we just created a new adapter for in-chain code transactions or invocations, whatever how you want to call it. Uh, Another topic that we'll be covering on today's session is going to be a little bit of unit testing. Some of you guys in the community have shown interest in how to properly make unit tests, or how are you supposed to test the controllers heavy. So we can show a little bit of that and a little bit of complex objects using convector model. Uh, Walter wrote an excellent tutorial in our new documentation site. If you haven't checked out the documentation yet, the link is in the description of the video. Um, but basically, he created a new tutorial showing up from starting from the chain code, going through server, unit testing, querying database, all the stuff that you need to do on a real application. And he didn't the example with just a naive example, for example, marbles or things just like pretty primitive like that. He created a new model using for you as a person, as a citizen, and in envisioning that the government is going to have a centralized, a registry in a blockchain where it's not going to be centralized, it's going to be distributed between multiple participants, but he has the rights to, for example, enroll new users to this registry, like giving the citizenship to a citizen. So he created a new model. I'm going actually to share my screen to show a little bit of the tutorial he created. So he basically, if you go here to the new docs.worcv.com, and you click on Convector Smart Contract, you're going to find the tutorial here. So it's a tutorial smart contract, and you will see here, like the example is centralizing the point of view on a user, on you, the citizen, and there will be a government proving that, for example, you exist on this country. But the idea is to also bring attributes to this model. So there will be different institutions, there will be banking accounts, there will be universities wanting to give properties about yourself as a citizen, like for example, that you are a graduate, or that you are insured, or that you have a car, that you have a house. There's different aspects that a blockchain can support, and at the end, that's the idea of using a blockchain, is to have some data that can be shared between different parties, and this data can be used across all different parties. This, for example, is an example of what we could use to make interchain code calls. For example, right, Walter wrote the tutorial using a single chain code. If you follow the tutorial, you will see everything is going to be packaged into a single chain code, all the different controllers, and they can be deployed to a channel. But an even more rich example of this will be this being deployed to a channel, and each of you guys watching the video, if you want to create, for example, an application, and you want to consume one of the data in this application, you will have to make a cross-chain code invocation. So you will have to invoke a different chain code within your chain code. And this is actually the adapter that I'm going to show you just right after the intro. So let's get to it, actually. So a little bit of hands. DD encode. So as I tell you, the code is in a pull request at the moment. It hasn't been merged yet into the develop branch. If you want to come pass by and give us a hand to test it out very well, please let me know in the Discord chat that you want to try it, and I can give you an alpha build version number that you can install in your projects and try it right away. Otherwise, you can just wait for a release when these other fixes and features land to the next version of Convector. So pretty much we have a new Convector adapter fabric in chain code. So this is going to be a new adapter. So you are really used to use the fabric adapter for your Express applications, for example, to make invocations to the fabric network, right? That's the purpose of the fabric adapter when you are writing an Node.js application and you have your controllers and you have your models and you have already installed your chain code in the blockchain. You will be using the fabric adapter to make invocations to the fabric network. In here, we're creating a fabric in chain code adapter, and this adapter is going to be used and created from inside a controller. So because the idea in here is that you can call a controller that is, or another chain code. It can be a chain code written in Go or even in pure JavaScript. It doesn't have to be a strictly convector controller, a convector chain code, sorry. But the idea is that you can do both of them. So in here, I have an example. I'll start with second. I have an example controller. It's called seconds. Well, this is a model. And it extends the convector model. This is a simple model just to test out the functionality in the pull request. This second model only has three items. The ID, all the models have an ID. It has a type, which is IO words per second, and it has a name, just that. And we have another controller. We have this controller, a second controller that extends convector controller. It has just two methods. It has an init that receives a second, which is a model. It's a parameter. It receives the whole model, this model that we got in here. So it receives in here in the data variable. It has the whole object with the convector model. And what it does is simply saving it to the ledger where this chain code is being deployed. What we have as well is a method called get that is going to receive a parameter with ID, the ID that the object that we want to take it back. And we're simply calling second.getOne, passing the ID, and converting it to a JSON object. So one thing, now that we're talking about this, some of you guys in the community have asked some questions about the flat convector model. Flat convector model. So first, start by describing a convector model. Convector model is a class extending convector model, and at the end, if you use or if you try to access any of the properties of this method of this class, it's going to be second, new second. And if you come here, and since I'm using VS Code and I'm using TypeScript, if I type something, it will try to autocomplete. I will type second. And if I write dot, it will show me all the properties and methods that this second object has. And it has, you can see it has an ID, it has a name, and it has a type, just the ones that I have in here, type, name, and the ID that is implicit that all the convector model has. But it also will show you other methods, for example, clone, delete, fetch, history, save to JSON, and update. All those are methods from the convector model. So those are rich methods that we put available to you, so you can clone and query the ledger using just model, right? When you grab this in a flat convector model, flat convector model, actually this is just a type. So let's put it like this. So if I state that this second is going to be a flat convector model, what I'm doing is taking all those extra methods, as extra helpers that I give to this object. So if I type second, that I'll only have name. Type and ID got removed just by applying convector model, flat convector model. And this is helpful for when, for example, the output of a method like toJSON is a flat convector model, actually. The output of JSON will include the ID and the type. But this is useful. This flat convector model is useful for when you have to embed another model inside another model. So for example, if I come here, let me see, for example, first. That's it, yeah. Yeah, I don't have a model here. Okay, no worries. I'll create just another model on top of this one here. By the way, if you have any questions, don't hesitate to write them in the YouTube comments. I'll be checking out constantly, or write them in the Discord chat. So I have another model here called third, and this third is going to have just age. It's going to be a number, just to demo this number. If I want to embed a third object inside second, and embed is like copying all the data inside a new instance of second. It's not a reference. It's not going to be a reference. It's going to be just a copy of the object. I will create a public third, and this is of type flat convector model third. So this is going to be a validate using third. And since third is a convector model, it acts as an schema, as a JIP schema, so I don't have to do anything else. So if I do this and I try to create a new instance of second, do that, const second. And I type second dot third age. You'll see it just show me the age. If I remove, for example, this flat convector model, and if I do this, it will show me that I have all the methods. But this is not going to be correct because the data that is going to be stored in here is not a convector model. It's the data, there's the value of that convector model, the JSON representation of that convector model. So this is actually not accurate because when you instantiate, when you for example do a second that get one and you pass an ID, what you will get back const second. Well, the wait is not going to work because I'm not inside a signed function, but let's pretend it does. This new second will have a property third, and that property is going to be a JSON. It's not going to be a convector model. It just went to the blockchain, extracted all the information, which is a JSON. What we store in the ledger is a JSON, and it will stamp it in the third property. So that's why it's not accurate to put this like that. You have to put a flat convector model and third. We're working though on a new feature, which is going to be to dynamically for Convector to dynamically validate and recreate this this model that you're storing here as a rich model that you can link and use as a reference to the another actual record stored in the ledger. But this is not actually on the framework right now. So whatever you will store in here is not going to be a model, a complex object. It's going to be just a JSON. So that's why you need to use flat convector model. Okay, let's remove this and continue with the example I was giving you. Right. So okay, so this is our second controller. It's going to be two methods, init and get. I have another third controller actually in here. It's called third. It has the exact same thing as second. It's a init method and it has a get method. And the reason that why this is exactly the same as second is just for testing purposes. I was testing this new functionality of Convector interchain code communication. So theoretically, in our unit test, second is going to be stored in a different chain code than third. So they are going to be packaged differently. They are going to be installed in different channels, actually. But we will be talking to both of them using first, for example. So using first controller, I have first controller in here. And I have two methods in this first controller. You will notice I don't have any model for first. It doesn't need to. It will be working with the models of second and the models of third. And the invocations I'm going to be invoking both of them, second and third, from within inside the first controller. And the way that I'm going to do this is by creating outside from the controller. I will be creating a new adapter, which is going to be an instance of in-chaincode adapter. This is going to be available inside the platform fabric package from Convector. So you can install it using import, or you can import it, sorry, using import or Cibu Convector platform fabric. It's going to be available in this package. I thought it's going to be available in the Convector Adapter Fabric in chaincode package as well, but I don't think you want to install it separately. It's going to be probably all just bundled in the Platform Fabric package. So, okay, so you will create in this a new adapter, and I'm going to make use of the client factory feature that we released a couple of weeks ago. So the client factory is going to be the point of access to this controller. So I pass the client factory and I pass the second controller, which I do have access to the source code in this theoretical example. And I will be passing the adapter and done. This is going to initialize a second controller. This is going to be a client or call to make calls to the second controller. And then inside in the first controller, in the contact to second call, I'm going to be receiving the ID, the channel, and the chain code, the name of the chain code that I want to invoke. So the ID is going to be a query to the same code, to the second chain code. Channel is where this chain code is being installed, and chain code is the name of how this how the second controller was bundled in a single chain code, and what is the name of that chain code. Okay, so in order to invoke this second controller, I'll be using this just like I do from the outside wire. For example, I'll be invoking this in the same way that I do unit testing or invoking chain code from within the Node.js server, for example. So we have this second controller, which is client factory. If you remember, we initialized it out in here. I will pass in some configuration. I will pass in the transaction. It needs me to pass the transaction. In the transaction is the stop method, and the stop method in Fabric is the one that allows me to make calls between chain code. I'll be passing the channel, and I'll be passing the chain code. Those are coming from the parameters in here, right? And I will be invoking the get function inside second controller. If you remember, we have second in here. We have a method called second. It's called get, sorry. And it just receives an ID, goes to the ledger and finds that ID and return me a JSON of that one. So that's just basically what is going on in here. So the only difference is that I'm passing a configuration to tell the controller where to find or where to invoke this method. Second thing I'm going to do is I'm going to create a new second model. I'm going to assign an ID called second and the ID of the model that was asked and the rest of the body of second. So this is going to basically copy second and just change the ID of this model, and it will store it in whatever first is being deployed. It can be a separate channel. So for example, we can be talking that there is 3 channels in this example to make it more clear. And I will just return the JSON return as a second. That's it. That's the invocation to connect to second. How we call this, I'll show you the unit test that calls this, is we create a mock controller adapter for the first. This is going to emulate like creating a new ledger just for the first controller, a new ledger for the second controller, and another ledger for the third controller. So we have in here initialize the first adapter is going to be, mock controller adapter. We initialize a client factory passing the first controller in the first adapter. This is going to be just an instance of first. And we initialize the mock blockchain just by telling it, okay, this is going to contain this controller and it's going to be located in here. We do the exact same thing for second and third. So second has a second controller, and the second and the third adapter is going to contain the third controller. So this example in here is mimicking like having 3 separate blockchains, having 3 separate channels, because they don't share data. They don't share data by default between them. The way that I configure the mock, the stop, to be able to connect them and make them visible is by calling first adapter and stop. I'm going to mark a peer chain code. This is a method from the ledger. If you know the ledger guys, we have this fabric mock. You can find their documentation here. See, you go to, we are the ledger / fabric mock stop. This is where the engine for the mock adapter that is coming right now for Convector. So if you go to the docs, you'll find in here all these methods. For example, mock peer chain code is inside. Let's see. Here is mock peer chain code. There you go. So it registers a peer chain code within the mock stop. So it basically, in plain English, is going to be just tell the adapter, tell the mock chain code, the mock ledger that it is creating, that is going to act like if you add a new channel in Fabric, for example. And I'm registering the second. This is the name of the chain code that I'm going to be installing in this network, and CH1 is going to be the channel of this network. I'm passing the second adapter that stop. The same thing for the third / CH1 and the third adapter. So this is going to be this is going to make me able to invoke chain codes for unit testing. For real chain code applications, you don't need this. So what you need on real blockchain applications is just make sure that the same participant that is going to be executing one of the transactions has read access to the other channels. That is going to be like the caveat on a real example. Actually, you can just run all these examples using Harley, but because on Harley, all the participants has write and read access to all of the channels, but you can make some rich and configurations with Harley just by editing all the configurations yourself. So you can set up the project or the examples as based on your needs. So, okay, so after initializing all this, I'll be running some tests. It should invoke a function in another chain code when you have the source code. So this example that I'm showing in with second, you see that I'm invoking or that I'm importing here the second controller and the second method. This means that I have the source code of this two of those two controllers. This is not always the case. For example, if, for example, you are an application trying to invoke a chain code in the same network, but from another company, and that another company just gave you, like, for example, the API, the overview API of their contract, or another case might be that this another chain code is written in Go, for example. So you won't have any controller or your second. So for that case, uh, we're covering also the third. The third is making a raw invocation. I'm going through this in a second, but it's going to be making a raw invocation without having the source code. Let's finish first with the second. Okay, so I'm going to first initialize in the second controller that we need. Remember, this is going to be starting a new model inside the second ledger. And this data with this ID1, shouldn't be available to first and to third. So if I go to the first controller or to the third controller and try to query for the ID1, I won't be able to get this ID because it doesn't share the ledger. It's a completely different ledger. So I'm going to create this model in here, and later I will be calling first controller connect to second, and this is going to be using this inner controller invocation that is going to be to first and send an invocation to second controller. I'll be querying the one. If you remember the code, it is called to get, and it passes the ID. It receives three parameters: ID, channel, and chain code, and that's the thing that we have in here. The ID1, I will get the ID1 that I just stored in second. The channel CH1, which is how I registered this in here, and the parameter second, which is the name of the chain code that I give to this chain code. Is you can find that in here in the unit test. And it's going to, if you remember the code, it's going to make the invocation, create a new model, and start it in the ledger for first, right? So if I go to the unit test, back to the unit test, it should return at the end the model that it found, and it did so. If I run the test, this will pass. I will be running after the explanation, but if I do a second that name, it should be equal to casa. And as you can see, here is the proper value for this one. The same thing happens for the third controller, for the third invocation, sorry. The difference with third is that I don't have the source code. I don't have the controller or the model to invoke this. Well, I do have the model, but this was just to make the example clear. But I do not have access to the controller to make the invocation. Like in here, you remember I did a second controller config, pass all the configurations, and I call get. And this, in order to have this, I had to import second controller from here, second chain code, right? But for third, I'm trying to emulate that I do not have access to the third controller. So how I'm going to invoke something that I don't have access. And this is, as I tell you, this is going to be a common example, a common scenario, because of chain codes written in Go or chain codes written in, for example, Java is now becoming, or if any other language, and you want to invoke a chain code written on that other language, it won't have a convector controller, right? But you can still make invocations to those chain codes by using an adapter, raw invoke, and you write it in this notation. Third is the name of the controller. Get is the name of the method. This is plainly explained in our documentation side. This is how we register the names internally inside the chain code. Here's the name of the controller. Here's the name of the method. This is because you can have multiple controllers in a single chain code. And we pass the configurations like this. Transaction, channel, and chain code is the same thing as what we did in here. And we invoke it to pass the parameters that we need. So since we only need one parameter, we pass that parameter in here, which happens to be a string, the number 1. And this is going to be doing the same thing. I'm going to get the third model, and I'm going to create a new third model with a custom ID and the rest of the third model, and save it to the blockchain. And in the unit test, the invocation of this method is going to be no different. under one, I just call first controller, connect to third. This I pass the ID that I want to get, and which happens to be the same one that I store in here in Casa, in second controller, sorry. But it's not the same because remember it's a different ledger, so they are all different layers. Uh, you can say that there are different blockchains, for example. That's a layer at the end. And yeah, you pass the channel where this is installed and the name of how is it going to install in this new channel, and you make the test. And if I run this, let me run this. MPX, Bernard, Zach, PM1 test, or where's you Convector Developer Office chaincode. And yeah, run the test for that. Oh, sheesh, I'm not on the right directory. There you go. This. Okay, while we wait, okay, started. Whoa, we got a new error. No package found that match the words equal convector adapter fabric in check. Oh, it was my bad. Spelling this out. Let's see where the error is. Let's find it in the package JSON better. Remember, if you have any questions, you can write them in the YouTube channel. I'll be reading up before the call. It's almost the hour already. 40 minutes. This one is. Right. So it's going to be executing this unit test that we got in here. I just have to hit clauses. Just to give you some comments. So I read the other day on the Discord channels that some people were asking like how to make validations in Jup using enum, so or using multiple values. So you can see here the past, and you can do that very simply. You can let me see, Convector. Where's demo? Here's demo. Validate enums. Okay. So if you have an enum like this, for example, you type, you have 1, 2, and 3, and you happens to want to accept a new variable on the const, you have a const data that is going to be one of those values. So if I try to assign this, it's going to const data. Physical voice values never read. Fourth is not assignable. Okay, you see, type fourth is not assignable to the type, right? Type is an enum, and it only allows one of those two values. So if I put this, that error, okay. If I type this type one, okay, it won't complain that this is not an actual value, right? But how can you achieve some UP validations using this? You can do that by doing UP a string and typing that one off. If you can go to JUP and check out their all their methods, because that is pretty useful. That will be awesome because it has a bunch of different methods that you can use on your models. For example, if you have a string and you have an URL or an email, you can just simply validate that by calling that email in. And that's it. So, for example, if I type here, email, we'll try to validate an email. But one of the methods is one off. You can find them in the mixed. Where is it? One off, one off. Here it is. One off. You will see it receives an array of values, and you apply it like this. One off, Jimmy or 22, 24, 22. So you can do the same with a num if you put a snippet code like this. Object that types that key, sorry, and you pass the type. This is going to give you all the keys. But the keys of an enum is 0, 1, 2, 3, 4, etc., etc. Those are the keys of an enum. But you can just do a map of that array of numbers and map that number to type. So type sub 0 will be 1, type sub 1 will be 2, etc., etc. So you can, with this, you can achieve this very easily. You can also make a helper as well. So function or const write to enum to array, and you pass the enum here, and you return this. What's going on? Expression. Okay, enum. Let's say it's an n. And if you put this like this, you will have a helper that you can pass a num, for example, type, and boom. So you will be able to use job to validate that data or a property. You know, this is for models, or when you do something like this in here, job validate. You can put job that one off in here, job that string that one off with this kind of a snippet. So this is in our question this is in a comment in the question channel, but we'll be putting up this in the commentation, so you can do this pretty easily. Right. So back to the unit test. It did complete correctly. So you can see here, if you inspect all the data, you will see will be init controllers, init controllers, and there you go. We call to second init with this kind of data, and then we call to first connect with the parameters that we specify in the unit test. And this is going to be calling when you call to first connect inside the first controller. You remember there was an invocation to second get, so it's going to be performed that in here, and the test ended correctly. Now the second test is a third that init, where we initialize the data, and we call to first connect to third. Is going behind the scenes is going to call to third get, which is in here, and at the end we ended correctly with the right value. So this is going, as I told you, this is a PR, a pull request that we have in GitHub. If you want to try this right now, you can give it a try today. Just let me know. Just ping me in the Discord channel if you're interested to test it out. Otherwise, we'll be probably releasing this in a couple of weeks with this and even more with more features. So I think there is no questions in the YouTube. Let me just check. Yeah. All right. So moving on to the next topic that we'll be covering was a little bit of overview of this tutorial that Walter wrote. You can check it out. The source code is present if you go to GitHub. Works you do Convector as private data. No, it's not private data. Forgot the name. People attributes. Sorry. People attributes. Oh, people attributes. Let's check. Go to the word C. And you will find it in here. People attributes. Okay, so there is the source code for the project. You can come here, go to packages. How do you set up? No, I don't have. So in here, it basically, Walters, if you go to the tutorial, we'll cover all the situations where it's basically a government registering you as a citizen in a country. So he is the only person in charge of adding um, new citizens to their country. And this is being done by using the identity pattern. So if you go here to the participant model, we have a participant, which is a name, the name must be an array of identities, the same as the identity pattern example that we have up there. And one of those identities or the model of that identity is just a status, which is going to be true or false, if it's active or not, and the fingerprint of their certificate. And the controller for this one is going to be a register. So let's see. Yeah, so this is going to be a method that each of the participants call and to register themselves in the blockchain, right? We also have a person chain code. And this person, we will have the attributes in here. Oh, sorry. It will have a person. The person is going to have a name and the attributes. Attributes is going to be another convector model. So you can see it reflects the values of this. It's going to be an array of attributes. And this array of attributes, each of them has a content of the attribute. An attribute is just like an entity proving that you as a citizenship has something, a car, an insurance, a degree, some certain years of experience in a company, something like that. Uh, it will have an issue date whenever this company attaches this attribute to you, and it will have an expire date probably. So this expire date is going to be optional. Um, I yeah, I think we're missing the option here. Uh, it's going to be an expired, which is our calculated property if the expired date is already over, and you will have a certified ID, which is whoever added this property to you. So this can all track all kind of information within this blockchain. For example, imagine you are a person and you went to a university and you earned a degree in this university. Uh, Instead of you having to prove to other companies or some other institutions that you have a degree expanded by a certain university, if the data will if that data will be on a blockchain, it will be much more easier. So the university registers themselves in this blockchain as a participant using the participant modeling controller. They register themselves and they attach a property to an attribute to you as a person. And with this in the content, they can put the information about this degree. They only the only participant that can update this kind of information will be this university themselves. So it's pretty useful to demonstrate kind of things like validated by other companies. So if you went to a job interview and you want to prove that you have a degree given or earned in this specific university, um, they can do so by just entering the blockchain, and if they have the right permissions, they can read the data that the university certified with certain ID. The ID is going to be a participant. They can have all the cryptography, making sure that only that university could have attached this attribute to you, and they will have the data for this degree. So it's really convenient. Uh, and this is a basic but still complex example that you can follow in the tutorial if you want to take a look at more. Um, I'm not going to spoil you all the details of this demo. I'm actually just encouraging you to go to the tutorial. If you go to docs.wordcv.com, uh, the article is 89, or you can just come here to Convector Smart Contracts and click on tutorial getting started. It's actually a series of different tutorials. The first one is explaining the example. Second one is about the smart contracts. If you are interested in doing backend with Express, you can take the third one which is about backend. We do also have a Convector REST API generator, and for this one you can use this. this tutorial. And if you are more interested in making rich queries with CoachDB, which now you can pass some indexes as well to the queries, you can do so by following this tutorial. Walter covers most of the work. You can work in CoachDB with views, with pre-rendered views or calculated views in the CoachDB engine, or you can also work with indexes. Call the coach to be directly indexes. There you go. So if you come here, you will follow the tutorial. You will learn how to configure indexes for your coach to be and make rich queries for it. All right. So it has been 50 minutes already. Um, I'm checking for questions on YouTube. I think there's not. So, Rogelio, can you talk more about the why get ID can return something valid even if the certificate was renewed? So, can you talk more about why get ID can return something valid even if the certificate was renewed? Um, I don't quite understand your question, Rogelio. I don't know if you can explain us a little bit more, even if the certificate was renewed. All right. All right. Let's see. Let's give it a couple of minutes just to make sure this is still there. Sorry, I didn't see the question before. Yeah. All right. All right. If there's nothing else, even though Rogelio, we can continue conversating, talking on the YouTube comments, or you can ping me in the Discord channel to clarify your question. Yeah, I don't quite understand it. All right. Yeah. So, okay. Thank you very much, everyone. Please stay tuned for next Convector Developer Office Hours. We'll be trying to be covering more and more examples of rich things that you can do with Convector. And we'll be trying to focus a little bit more on backend and on college DBs. I heard somewhere that there is a member in the community trying to create a new backend using Nest.js. Nest.js is a Node.js framework to create backends using Express, and there is someone trying to integrate that with Convector. So as soon as they have the examples ready, we'll let you know on the Discord chat. So if you're interested on that, please let us know, and or please keep an eye on the Discord, and we'll let you know when this is ready. All right, guys. Thank you very much again, and see you next week.